Remember, if you have a question, raise your hand.
We're going to go over this. How do I change the... Okay, so these are 2D figures. So shapes are 2D figures because they're flat. There's nothing to them. There's a picture of a scientist. This is a 2D figure because it's a picture. And then this is a playground. It's a 2D figure of a playground. So I also brought in a 2D figure of the globe. If you look at it, it's flat. There's only length and width, but when you look at it from above like a bird, it's not 3D. If you don't see anything, nothing's popping up. But I also found a map that has a diagram of the world, which you can all see. So if you talk about diagrams, you made them in your books yesterday. This bottom one, it made all the continents. It's a diagram, it's a squares, because diagrams, pictures, and maps are all 2D figures. So what's the definition of a 2D figure? Taimi? A 2D figure, two-dimensional. Brian?
Flat.
Anything flat. You look at it from a bird and you're flying over it. If you look at this from above, Taimi, can you see, does anything pop up? Does anything have height? Is there anything where my hand is? No, it's 2D, it's flat.
No.
Okay, so these are 3D figures, which you're going to be using today. Construction paper. Oh my God, look at that. I knew you were going to say that of all of them. I knew you were going to like it. So if you see here, this is a coral reef.
Really?
This 3D figure made out of construction paper can help scientists see inside the coral reef, on top, like what are all the twists and turns of the coral. A tree house you can show, because there's all these faces, which help make it have 3D. And then the animal, if you're going to make an animal, it cannot just be an animal's face or body. It has to be 3D. You see how there's a shadow underneath all the iguanas and lizards?
I'm making a
So you have to make a 3D model that a scientist can explore and investigate with. So if you look at the iguana, they can see the spots it has, how many legs they can investigate. If it's accurate enough, they can see how thick the iguana is. So you're making 3D models. Yes, Axel?
Maybe if you finish something really fast, can you do other things?
What do you mean?
If you finish with what you want, maybe you can do the house.
Yeah, you can do two if you have time. I also have 3D house cutouts you guys can make from a paper where you can pull the picture and make a house. I have those too. But you're first going to do it with construction paper on your own. So this is a 3D model of the globe. It's different than the other one we saw because look, I can see below it, I can see above it, I can see from the sides, I can spin
Can you
it.
touch it?
You can touch it later. It's going to be here all day. So why is this 3D? What's different with this than what was in one of the maps here? What's the difference between this 2D model of the world and this 3D model? Kathleen? It's not flat. There's height to it now. When I look at them, if I put them both on Jemiah's desk, Jemiah, which one has height? This one, because it comes up. It's 3D. You can see from above it, below it, on the sides. This, if I look underneath the map, I see the cover of the book. I don't see the other side of the globe. Just one globe. Yes, Dry.
You can examine it, like you can look around.
I can examine it better, right? The paper, it's flat. I can't see across.
And you can see other countries and states.
And I can see countries. I can see states. See Antarctica. See the equator. Yes, Sophia.
The map is also flat.
And what is this? What shape is this?
Sphere.
A sphere. It's 3D, three-dimensional. There's height, length, and width. Three-dimensional. Yes, Timmy. Yes, the map in the book is 2D and this is 3D. So there's one more model which you guys did yesterday. Show. Yes, what's that? Yes, because it can go into a holder and it can help you measure, because they pointed out. There's measurements on the other side that holds it. Okay, so now this is a computer model. We can see. Can I touch it? Move.
Should be able to.
Use Google Earth. See, we can move the world. It's a computer model. Lets us see from outer space. We're looking from above using a computer.
But there was something, there's something in the sky, out of space, you can watch, you can watch us while we do it.
Yeah, they use satellites to make it. So you guys made computer models yesterday. As you see, there's a difference between all three models. Yes, Axel.
What? But this is like 2D too.
It is in a way because it's on a screen. It's flat, but it's 3D because we're a computer model because we're looking at it from above. Look, what is that? What town is that? Bound Brook. See, we can see into Bound Brook. We can move around. We can see 287, 22.
Oh, here, right here.
Look, there's the ShopRite, Bound Brook Apartments.
Oh my God, what's ShopRite?
ShopRite's right there.
Great.
See, in the computer model, we can get even closer than the 3D model. We can't zoom in on this. Look, there's Cherry Ave. There's us.
I want to know my house is.
But we're not going to find your house. Okay, but what's the difference between this globe, that's 3D, and this computer model? What's the difference? Christopher. The globe does pop out, but what if I'm observing the globe? What can I do on the computer model that I can't do on this globe?
Look closer.
I can zoom in. I can't take my fingers and zoom in on the globe. Asia's not getting any bigger. It's as big as Asia's going to get. But on a computer model of the globe, we're able to zoom in. And look, we found Smalley School. Yes,
You can't like move and switch to other town.
no, we can't switch to other towns. I can see all the states. I can find New Jersey. But I can't zoom into New Jersey.
Wait, I have a question.
What's what? On this? This line? What line is this, Ryan?
Oh my God.
Was this? Oh, to help you measure when it's inside this shows you how to measure it to line it up correctly so you get accurate measurements. Okay, so today we're making 3D models. We made construction paper. We made computer models yesterday. We made 2D models the day before in your science notebooks.
And the airplane.
What, Trey? Well, if you look at this picture, it's a sunny photo, which leads me to believe it was taken another day. It's not that sunny outside. A little shady out there.
A good inference.
It is a difference. All right, so you're going to make 3D models. You are going to be given scissors, glue, and construction paper. You can make it of anything you want. You can make it of the coral reef you saw, of an animal, but the animal has to be 3D. So it means it has to stand. It has to have height. It can't lay flat on your desk. It has to stand up. Or you can make the playground, or your house, or anything that is 3D.
People made cars last year. People made robots.
And the other thing,
All right, Axel just made another point. When we look at the globe, we can't see ShopRite. I said Axel. We can't see ShopRite, but on Google Earth, we're able to see ShopRite. Okay, so this will be up for you guys to see if you want to make a replica of the ocean, or a house, or a lizard. It has to be three-dimensional. Yeah. Who's teacher's helper and supplies?
Dre.
Christopher.
Do you have a question, Dre?
Urban.